Hi, today our notes are on section 5.5, operations with functions, and we're actually going to switch gears a little bit today. We're not going to be solving radical functions anymore. We're going to be combining two functions using addition, subtraction, multiplication, and division. So first off, f and g are any two functions, and you can combine them to create a new function that can be defined by performing any of the four basic operations: addition, subtraction, multiplication, or division on f and g. And so if you notice, the way that we notate this is that if you do f plus g of x, right, it's the same as f of x plus g of x. And so what you can do is you can do this two ways. You can actually combine them first and then evaluate it, or like simplify it. So notice here we take f of x, which is 5x, and we add it, because it says addition here, to g of x. Now the only thing you want to be careful of is your parentheses, because here if we're subtracting g of x, then we're subtracting both x and 2, right? So it becomes 5x minus x and minus 2. If we're multiplying, all we're doing is we're multiplying the function. Now this looks really simple and basic with linear functions, but as we move on and we go into like cube roots and different radicals, we're going to use the properties of radicals to combine them together. So let's start off. Finding f plus g of x means that we are adding f of x plus g of x. Right? So if we replace those, then it's really just 2x plus 12 plus 4x minus 8. And since it's an addition problem, we don't need parentheses, and we can just combine like terms, which is 6x plus 4. And so your final notation is f plus g of x equals 6x plus 4. This one will be the same thing, but we're going to subtract. Like I said before, you just have to be really careful. 2x plus 12, but we're going to subtract 4x minus 8. And so when you distribute your negative, the signs change. Right? So right now this 4x is positive, but it's going to become negative. 2x plus 12 minus 4x plus 8. And so I'll write it over here. F minus g of x equals negative 2x plus 20. And so the only two things now are we're going to do multiplication and division as well. So if you feel like you're able to do that without me, feel free. That's f of x times g of x, which means that we are going to be multiplying 2x plus 12 times 4x minus 8. And what you're going to do is distribute, or box method. And f times g of x equals 8x squared plus 32x minus 96. And lastly, if we're dividing, we're going to take f of x divided by g of x, which is, let's see, 2x plus 12 over 4x minus 8. Now this one you want to be careful of because we do have to simplify more, but you can't just divide x's and numbers, right? So in order to divide, you have to factor first, which means I have 2 parentheses x plus 6 and 4 parentheses x minus 2. Notice that I factored out using the GCF. If it's a trinomial, you would factor the trinomial, right? So this is just where it depends on what you're given. And so 2 and 4 can be reduced to 1/2. And so we would get, let's see, f over g of x, oops, sorry, equals x plus 6 over 2 parentheses x minus 2. And you don't need to distribute to like unfactor anything. So once you factor it, you can leave it as is. Okay, so let's do a few examples with radicals now. Let's see. So there are a few rules that you need to know about radicals. If you have radicals and they have the same, let me write this in, with same radicand and same index, those are like terms. Okay, so I'm going to just do a big bubble around this. So remember, we can add and subtract like terms only, right? So if I'm adding these two together, I'm going to have negative 1/2 cube root of x plus 9/2 cube root of x. Okay, so here's what you need to look at. If these are like terms, this is almost like saying negative 1/2 x plus 9/2 x, right? So really what we're doing is we're only combining the coefficient in front and we're ignoring these two. So 9/2 minus 1/2 is 8/2 cube root of x, which is the same as 4 cube root of x, equals f plus g of x. We can subtract the same way. Okay, I'm going to let you guys practice that. See if you get, here's the answer to check, negative 5 cube root of, oh sorry, let's do this in a different color so it's not all red right there. Negative 5 cube root of x. Okay. Let's see. Now, multiplying is a different property, right? So don't just multiply the coefficients anymore. When we're multiplying, we have negative 1/2 cube root of x times 9/2 cube root of x. So you have to multiply, like, I guess you have to multiply like terms. You could think of it that way, right? So really what you're doing is, I could rewrite it. It's not multiplying like terms. It's just multiplying what you can. So could I separate? Because these are each multiplication problems on their own as well. So I'm going to rewrite it in a different order. So negative 1/2 times 9/2. Hopefully you know an answer to that. And then we can go cube root of x times cube root of x. Okay, so really what we've done is just reorganize these, and we know that this is going to be negative 9 over 4. And when we multiply, this is really x to the 1/3 times x to the 1/3. Right, so this is rewritten in exponent form, because that might help you realize that all we're doing is we're adding the exponents, so the denominator or the index doesn't change, but we're going to have a 2. Which makes sense because now instead of just one of these, we have 2 of them. So really all it is cube root of x squared. And you can write the squared inside or you can write the squared outside. Okay, so either of these works. I prefer this one, I think, because just keeping it a little bit more like condensed. But I will not take points off if you write it this way. Okay, next one. We're going to divide. Negative 1/2 cube root of x over 9/2 cube root of x. Okay, this one is sort of my favorite because look, these cancel out. And I hope you guys remember, but If not, let's go over it. This double fraction is just dividing fractions, right? And when we divide fractions, there's two ways to think of this. If you can memorize it, great. Hopefully some of you guys will remember that you just flip it and then you multiply by 2/9. I'm not a huge fan of that though, like the magic of like, why does it happen? I sort of like knowing that the reason why it happens is because we're multiplying by 2/9 here to get rid of that. And when we do fractions, anything you multiply the bottom by, you have to multiply the top by. Okay, so really that's why it works. But if you can just memorize this, that's great. It does work that way. So it's -1/9. So on the back, it's all pretty much the same thing, except there are limitations as to where you need to start and stop. So I'll go over a few. If you feel like you've got it, you may move forward and do this without me and the video. Please do check your answers at the end of the video though. Okay, sorry, let me get this. There we go. Okay, so the first things first, if we are adding you need to recognize that if these are not like terms, you can't add them together, right? Just because it's a cube, this is a 1/3, so think of it as like -x cubed plus 2x to the 1/3 power. Do you see how these two are totally different? So we can't combine them. Either of these is your final answer. Remember, for you to be able to combine them, you have to have the same radicand and the same index. So same goes for this one. You won't be able to combine like terms. Okay, so you'll get -x cubed minus 2 cube root of x. I'm going to multiply here. And so I can rewrite this as okay, so if I wanted to condense this into one exponent or one radical, there's two ways you can write this answer. Okay, so this is one of those like sort of weird ones. You can write your answer as -2x cubed cube root of x. This is the simplest radical form. Right, because you have simplified your radical and there's not a bigger exponent inside, so like we can't take any more groups of x out. Or you can write this as -2x, and if you want to write simplest exponent form, we have to combine the x's and add them together, right? So over here I could do 3 plus 1/3. Well, that's going to be 3 1/3, but let's write this as a improper fraction. So that's, I'm going to multiply by 3 and 3, top and bottom. So that's 9 plus 1 is 10/3. Okay, so this is simplest exponent form. So let's stick with like simplest exponent form right now, just because, actually, no, let's do simplest radical form. Like if I give you radicals, let's say, and on the test I will specify, but let's stick with radicals and just review. Guys ready? So I'll have -x cubed divided by 2 cube root of x. Hopefully you remember that we can't have a radical in the denominator. So there's two ways to tackle this. You can rationalize the denominator, or we can change this to an exponent and subtract. Herein lies the problem of this chapter, right? So you could do it either way. It really depends. So I guess I could do both ways, and I'll show you guys. Okay. So the first way will be if I rewrote it. And so what I'll be doing is subtracting 3 minus 1/3. Well, that's, let's rewrite this as 9 and negative x to the 9 over 3 to the 2x 1/3. So I'm going to subtract my exponents, which will be negative x to the 8/3 over 2. And then this one, if I wanted to rationalize the denominator, I have 1x, but I want groups of 3. So I need to multiply by, still group of 3, but I need 2 more x's. So hopefully that makes sense. And that's going to help me come over here. So then I'll have 2x on the bottom, right? Because there's one full group now. And then I'll have negative x cubed, cube root of x squared. And what we need to do now is cancel out one of these x cubes with this x on the bottom. So you'll have negative x squared, cube root of x squared over 2. Now how does this become this? Well, if you rewrite this, right, to here, really what we have is negative cube root of x to the 8th power over 2. Well, there's 2 full groups of 3, so there's your x squared, and then there's 2 as a remainder. So it's the same thing. Okay. I'm going to let you guys try the last the last 4 problems. I'll write your answers in, but please show your work. Okay? So this will be some you can. So if you cannot, then great, like these first 2. I think the second one you will need to. Oh, and please rewrite these in simplest radical form. Okay? So since this is the radical chapter. Okay, check your answers, see if that matches, and I'll see you guys tomorrow in class.